Alright, so it says rational expressions and functions. Find the domain of the rational expression. The big thing with rational expressions is you got to look at the denominator. This is actually not a rational expression because you could just write this as 1/4 x squared plus 9/4. So the domain of this one is negative infinity to infinity, or all real numbers. Okay? Now see here, on this one, see how the variable is located in the denominator? That's okay, but what we need to do, because remember you can't divide by 0. So set denominator equal to 0, solve. So that means all real numbers except x cannot equal 9. Okay? So remember, if the variable's in the denominator and you're finding the domain, you set denominator equal to 0 and you solve. So we get t squared minus 16 equals 0. Add the 16, square root, t equals plus or minus 4. So the domain, all real numbers. See how I have the little extra line here? This means all real numbers, except x cannot equal negative 4 comma 4. So let's take a look at some more rational expressions. Now it says, so we got over domain. Now it says find the value of f of x when x is 15, negative 2. So all that means is plug in negative 2, and then calculate it. So you get negative 6 plus 5, negative 1. Negative 4 minus 4, negative 8. So it's 1/8. Plug in 15. And you get 45 plus 5 is 50. 30 minus 4, 26. So you get 25 over 13. Okay? So let's look at another example of just evaluating the functions here. So see how it says g of 0? That means plug in 0. So g of 0 equals 0 squared minus 4 times 0 over 0 squared minus 9. So you get 0 over negative 9, so it's 0. Plug in 4, you get 4 squared minus 4 times 4 over 4 squared minus 9. You get 0 over negative 9 again, so you get 0. Because 4 squared is 16 and 4 times 4 is 16. So plug in the 3. 3 squared minus 4 times 3 over 3 squared minus 9. This one you get 9 minus 12, negative 3 over 0, not good, undefined. Okay? Plug in negative 3. Don't forget to put the negative in parentheses when you're calculating this. This one you get 12. Nope. Sorry. 21. 9 plus 12 over 0. So it's also undefined. Let's take a look at some more rational functions. Alright, it says find all values for x such that 3x plus 5 divided by 2x minus 4 is true. So what they're saying is find the domain. So the domain, remember, set denominator equal to 0, solve. 2x equals 4, so x equals 2. So x can't be 2. So the values are all real numbers except x cannot equal 2. Okay. Now here it says simplify this. Now remember, I can change that. Whenever you see third, you have to think, what's the cube root of these? Because I get this. And remember, x to the third minus 3 to the third factors into x minus 3. X squared plus 3x plus 9. See how the x minus 3's cancel, so you get x squared plus 3x plus 9. Okay? So it says write in lowest terms. So what can I simplify with the 18 and the 6? Well, they're both divisible by 3, so you'd get 9 over 2, and then the r squared on top. Okay, let's take a look at some more. Simplify. So it doesn't look like we can do anything right now, but factor out common things. So if I factor out a 6 from the top, I get m minus 3. If I factor out a 7 from the bottom, I get m minus 3. Cancel out, you get 6 over 7. Okay, let's look at another one. So we're still simplifying. These look almost the same, except watch what happens when I rewrite it. Negative t plus 6 over t minus 6. I like to get the variables first. So I look, see how negative, positive, positive, negative? So watch. Factor out a negative 1. And see how when you factor out the negative, what's a negative divided by a negative? Positive. What's a positive divided by a negative? Negative. So these cancel out, so it's a negative 1. Okay? So do we see where we're going with these here? What can I factor out of the top? X. What multiplies to 49 as a negative 14? Negative 7, negative 7. Those cancel. I'm left with x minus 7. Here, I'm going to do two things. I'm going to rewrite and factor out a 3. And then I'm going to factor out a negative 1 from the top. What am I left with? Negative 1/3. Okay? Let's take a look. So what can I cancel to start with? Well, this b will take away one of these, so I have a squared, and then that changes to b squared. And then this b minus 3 will take out one of those b minus 3s, so I'm left with b minus 3 on the bottom. Okay? Let's take a look at some more. Okay, so we got to factor the top first. Multiplies to 36, adds negative 12, because a is 1, so 1 times 36. So it's going to be negative 6, negative 6. So you get u minus 6, u minus 6. So one of those cancel each other out, so you're left with u minus 6. I'm going to factor out x squared from the top. The bottom multiplies negative 15, adds to positive 2, positive 5, negative 3. Can I factor more? Yes. Difference of two perfect squares, so it's x plus 5, x minus 5. X plus 5, x minus 3. The plus 5's cancel. I'm left with x squared, x minus 5 over x minus 3. Okay? Let's look at another one. Now we're getting into a little bit of word problems here. Okay? So it says, describe the domain that cost C in millions of dollars for the government side to seize P% of an illegal drug as it enters the country given by this equation. Okay. So here's the thing. We know this has to not happen. That it can't equal 0. But here's the thing. So let's solve that first. So subtract 100. You get negative P equals negative 100. So P cannot equal 100. Okay, so we know that much. But here's the thing. If I plugged in over 100, if I plugged in 101, look at this. You get 528 times 101 over 100 minus 101. So this would be whatever that multiplies out to be over negative 1. Could you seize a negative amount of drugs? No. So we know we have to be strictly less than 100. And can you seize a negative percent if you're plugging in P as percent? No. So you could seize nothing, but you'd have to plug in. So there we go. So there's the domain. Okay, we got to think when it comes to domain of word problems. Let's take a look at some more. It says find the ratio of the area of the shaded area to the total area of the figure. Okay, so area of the shaded, x times x plus 1. Area of the total, x plus 3 times x plus 1. Divide. So it's x to x plus 3. We'll see you guys in class.